Okay, so last thing we're going to look at this week is the second part of section 4.2. And the goal in this section is going to be to solve triangles. Okay, specifically, we're going to solve right triangles. Does anyone have an idea what they think it means to solve a triangle? What do you think you have to figure out? Connor? Yeah, so how many things do you have to figure out? Well, yeah, you got to figure out two of the angles because they're always going to give you a 90. And then you got to figure out all the sides. Usually they're going to give you at least one of them, okay? Because they got to give you a little bit of information to start with. So to solve a triangle means find out the lengths of all the sides and the measure of every angle. So out of the 6 things, 3 sides, 3 angles, I have to give you 3 to start with. Well, you're always going to have a right angle, so that's 1. And then the other option is I could give you a side and an angle, or I could give you 2 sides. Okay, but I have to give you three things to start with. Okay, so when you're solving a right triangle, in addition to the 90, okay, that's just a given. You're going to have that. You need either another side and another angle, or 2 sides. Now, one thing I didn't put up there that I could give you is 2 other angles. How come that wouldn't help? If you already had one angle as a 90, how come giving you both of the other angles wouldn't be helpful? What do you think? Yeah, Peter?
Because the sides could be anything.
Right. Like, just for example, let's say I told you all the angles. I'm not going to use a right triangle, but just something simple. I gave you an equilateral. And I said all the angles are 60. 60, 60, 60. Well, you could have an equilateral. You could have an equilateral where there's all the sides, 60, 60, 60. And there's different sides, but the angles are still 60, 60, 60. Okay, so if all you know is the angles, all you could find is a triangle that is similar. You wouldn't be able to find exactly what the side lengths are. So in either case, you're always going to be given at least one side to start. Okay, so first what we'll do is we'll make a sketch using the information that's given. And then we'll organize that information in a table. Okay, the table is really just for us to figure out and keep track of everything we need to find. Okay. Now, when we sketch a triangle, we want to make sure that we put the correct side across from the correct angle. So if you're given, don't copy that yet, I'm going to come back to it. But if you're given information like that, you have to put it in a certain way in the triangle. So I'm going to show you how we do it. Right. Emily, what do we normally label the sides as? How do you label the sides in a triangle? What do you use to represent them?
Like A, B, and C?
Yeah. Is there any restriction on which one is which?
A and B are the legs and C is the hypotenuse.
Yeah. As long as you set it up so A and B are the legs, C is the hypotenuse. You could switch A and B. It doesn't matter. And does anyone remember from yesterday the name that we give to the angle that's always across from A? We used a Greek letter. Katie?
Alpha.
Yep. Alpha. It's always across from A. And does anybody remember the other Greek letter that's always across from B, right? Beta. Yep. You can sketch your triangle any way you want, okay, if you're just making a sketch. But wherever you put A, you have to put alpha across from it. Wherever you put B, you have to put beta across from it. Okay, always, however you sketch it, make sure you maintain that. A across from alpha, B across from beta. And that's always C. Okay, so let's solve that triangle. So this is the case where they're giving me a side and an angle to start with. If I go back up, it's that case. They're giving me a side and an angle. Okay, so the first thing I've done is I just made a table. I put the 3 sides in the left column, the 3 angles in the right column. And I put a box around everything I don't know. Okay, but that's what I need to find. I filled in B is 2 and alpha is 40 because that was given. So Matt, is there anything I can find there quickly without really doing too much work?
You can find beta.
Yeah, we could get beta pretty quick because we already have the other 2 angles. So what would beta be?
50 degrees.
Yeah, beta would be 50. Okay, so let's start to sketch that out and see what we're looking at. Okay, on my sketch, I am only going to label things that were given to me. Okay, so I don't know A, but alpha was given. B was given. I figured out beta, but it wasn't given, so I'm just going to leave it as beta. And I'm going to leave that as C. Okay, any questions on how we got beta? All right, now to find A and C, we have to pick an angle, not the right angle. You can't use the right angle. But you have a choice. You can use one of these other 2 angles to find A, and you're going to use one of these 2 angles to find C. Now, technically, you could use either one, and it would work. But which angle do you think is better to use? The 40 or the 50? Yeah, Victoria?
40,
Yeah, why is the 40 better?
because it was given to you.
It was given to you, and why? What could happen if you use the 50?
It could be wrong.
It could be wrong if you made a mistake finding it. So that's why when we solve these problems, we're going to avoid using anything that we found to find other things. Because if you make a mistake and you use that to find something else, then that's wrong now too. Okay. So we're going to use the 40. And besides an angle, you need a side. Well, we were given a side. So we're going to use the 40 because that was given. We're going to use the 2 because that was given. And let's find A first. So I circled the 3 things that we're going to try to use to make an equation. All right. So in our equation, we have to pick a trig function. Your 3 choices are either sine, cosine, or tangent. To figure out which one you use out of those 3, look at the 2 sides that I circled. The one that was given and the one you want to know. We just have to figure out the names of those sides from the perspective of the 40, like opposite, adjacent, stuff like that. So Mason, if I'm from the perspective of the 40, what is side A?
Opposite.
Opposite? How about 2?
Adjacent.
Adjacent. Which trig function, sine, cosine, or tangent, has opposite and adjacent in it? Tangent. Yeah. So we're going to set up an equation using tangent. And our goal is to find A. Okay, so it's the tangent of, Molly, what's the angle I'm using? 40. It's always the tangent of your angle. Equals, now we do opposite over adjacent. So Robin, what side is opposite 40? A. And what side is adjacent to 40? Which is? 2. Okay, so now we have to solve that equation for A. So Irene, how would I get the 2 on the other side and get A by itself?
To do the inverse of 10?
No, you don't need to use inverse tangent. We are going to talk about that later. There is going to be a time when you do need to use it, but not in this problem. Think if it was just 40 equals x over 2. That's pretty much the same basic idea. How would you get the 2 on the other side? Yeah, you multiply each side by 2. So you're going to do the same thing here. Times 2 times 2. Okay, and we do need to do that out. Okay. So we'll just type that in. Before I type it in, what do I want to double check on my calculator? Yeah?
Better degrees, not radians.
Right, I'm in the wrong mode. So if I type it in the way it is right now, I'm going to get it wrong. Every problem that we solve today is going to be degrees. And that's how it'll be on the test for these types of problems. Okay? You could do these in radians, we just we don't. All right, so I get about 1.678. Just round to 3. Okay, so that's A. So we can go back and write that in our table if we want. Okay, but we have it right there. Now, I know A and I know B. So what theorem could I use to find C? Yeah? Pythagorean theorem. But does anybody know why I would advise to not do that? Why do you think that might not be the best idea? It might be a couple reasons. Yeah? I have a decimal. That's not an exact answer. What happens if I use something that's rounded off to find something else? We rounded it, so now the other answer is even worse rounded because you're using something that's already not completely accurate to find something else. All right? So that's one thing. What's another reason why I might want to use 1.678 besides the fact it's rounded? Yep?
What if you got an answer wrong?
Yeah, it could just be wrong. What if the whole thing is just wrong? Then if you use A to find C, now C is wrong. So we're going to find C going back to the information that was given. So what's nice about the way I'm showing you how to solve it is you could make a mistake on one part, but you could still get everything else correct. Right? All right, so now we're going to use the 40, because that was given. We're going to use the 2, because that was given. And this time, we're going to find C. Okay, so focus on everything I just circled in green. Okay. So now our choices are, we're either using sine, cosine, or tangent. We already used tangent, so we're not using tangent again. Okay, because we're still from the perspective of the 40, so we need to involve a different side. We need hypotenuse. So Ryan, do you think you know what trig function to use? Cosine. Cosine will involve adjacent, which is the side we know, and hypotenuse, the side we don't know. Okay, so let's set up our equation for that. Okay, so now we'll find C. So it's the cosine of, Ryan, what's my angle? 40, yep. It's always the cosine of your angle, equals adjacent over hypotenuse. So Cameron, what side is adjacent to 40?
2.
2. And what side is the hypotenuse?
C.
C. Okay, and now we're going to solve that. Okay, my first step here is the same as the first step in the last problem. I want to get rid of having a fraction on the right side. So Orion, how would I get rid of having a fraction here?
You multiply by 1/2. Or, no.
Well, the 2 isn't what's making it a fraction, right?
Yeah.
It's the C. We're dividing by C. So we got to get rid of C.
So you multiply by, you just multiply by C.
Just multiply by C. Yep, that's your first step. Okay. I'm going to kind of put a box around the original problem, because I just want you to remember what that is, because I'm going to show you a trick in a second. So you multiply each side by C. Now you have C times the cosine of 40. Okay, I don't care what the cosine of 40 is. I'm just going to leave it like that. Equals 2. And Ashlyn, how would I get C by itself and move cosine 40 to the other side?
You would divide cos 40 from the first part, and then if you do that, it would move over to the other side too, equal out.
Yep, so divide each side by cosine 40. And there's your answer. So now just type that in. C equals 2 divided by cosine 40. 2 divided by cosine 40. We get 2.611. All right. So now, does anybody see what happened? If you look at what's in that kind of wavy box that I did, to get C by itself, there's kind of a shortcut, so we don't have to go through these 2 steps every time. Does anybody see visually what happened? Alex, you see how you could get C by itself? Just think more like visual. Don't think like multiply or divide. Just like what visually happened there. Sure. Ileana?
C and cosine of 40 squared.
Yeah, the C and the cosine 40, these two things, just switched places. Right? So anytime you've got something like, a number equals a number over a letter, okay, any situation like that, you can just switch what's on the bottom and what's on the other side to get your answer. That's all you have to do. If you don't like that, you can go through the same steps that we just did every time. But if you do it, that's what's going to end up happening in that kind of situation. Okay, number equals number on top, letter on bottom. Okay. Any questions on that? Okay, so now we've got all our answers. There's a couple quick things you can do to just look at it and make sure something isn't obviously wrong. The biggest side should always be across from the biggest angle. The smallest side should always be across from the smallest angle. If that doesn't happen, something's wrong. Also, you could do Pythagorean theorem and check if you do a squared plus b squared, does it equal c squared? Okay, that's another way you could check your sides if you have extra time. Do you think a squared plus b squared would exactly equal c squared here? No, how come?
Because we're rounding.
Yeah, because we rounded. But I mean, if it came out to 5.77 equals 5.76, then you probably did everything right. Okay. So you could double check it if you have extra time. Okay. Any questions on that one? Okay, what type of problem is this? Are they giving me a side and an angle, or are they giving me two of the sides? Ashley?
You're giving yourself a number.
Yep, it's the same as the last type. They're giving me a side and an angle. Okay, so take a minute, or maybe 2-3 minutes, and see if you can solve that. Technically, you can find anything you want first, because you're going to find everything separate. But there's usually something I find first because it's quick. Even though you're never going to use it again later, it's just quick to find it. Okay, so try that. If you get stuck, just call me over. I'll help you out. But we're gonna go through it. All right, so let's start to take a look at it and see how we did. So how about Connor? What did you find first? Well, do you see anything you could find first?
Alpha.
Okay, what'd you get for alpha?
7.
Yeah, how do you know that? Yeah, you have all the angles in a triangle have to add up to 180. Okay, so in order for that to happen, alpha has to be 70. Okay, now Paige, am I going to use that 70 to find anything else? Nope, I'm going to forget about it. I'm not going to use that for the rest of the problem. Okay, but if you have trouble visualizing what's going to be opposite and adjacent, the next thing I would suggest is to make a sketch. Okay, I'm going to put A across from alpha. I'm going to put B across from beta. All right, so I'm going to circle the two things we're always going to use. We're always going to use the 6. We're always going to use the 20. Now we have a choice. We can find B or C, and it doesn't matter which one we do first. So Matt, which one do you want to do first?
B.
B. Okay, so we're going to do B. Okay, Ryan, what's the name of side B from the perspective of 20?
Opposite.
Opposite. And what's the name of the 6 from the perspective of 20?
Adjacent.
Adjacent. And Hayden, what trig function would involve opposite and adjacent?
Tangent.
Tangent, yep. So we're going to set up an equation to find B. So let's find B. So it's going to be, Rudy, what's it going to be? Tangent of 20 equals B over 6. Okay, now I have one step to get B by itself. Haley, how would I get B by itself?
Multiply by 6.
Yep. Multiply by 6. Okay, and now type that in. Okay, so we get 6 tangent 20 comes out to 2.184. Okay, 2.184. Okay, any questions on that? Now, Brandon, could I do Pythagorean theorem to find C? Could I do it?
That's my brother. I'm Eric.
Eric, I'm sorry.
Sorry.
Could I do Pythagorean theorem to find C?
You could.
You could, but why is that a bad idea?
Because you're round.
Yeah, because we rounded, all right? We rounded. It might not be accurate, and it might not even be the right number. Okay, so we're not going to do Pythagorean theorem to find C. How about Irene? Could you tell me what trig function you would use to find C? Given that we're going to use this side again, this angle again, but now we're going to find C.
Cosine.
Yeah, we're going to do cosine. We know the adjacent. We don't know the hypotenuse. What trig function has those two? Just cosine. Okay, so let's set up our equation to find C. Okay, so it's going to be cosine of, well, Alex, cosine of 20. Yep. Equals what over what? 6 over C. 6 over C. Okay, and now Katie, what was the shortcut we had here that we could use to get C by itself? If we don't want to use it, we could go through the algebra.
Cosine of 20 and C switch.
But yeah, just switch C and cosine 20. So we get 6 divided by cosine 20. And that's C. Okay, so type it in and see what you get. Okay, I don't have to keep checking the mode of my calculator. It'll stay in degrees until I close it and open it back up. But if yours changes, make sure you keep checking it. 6.385. Okay, so Ileana, is the biggest side across from the biggest angle?
Yes.
Yep. How about the smallest side with the smallest angle? Yep, that doesn't guarantee we got it right, but at least there's nothing really wrong. Like we didn't write the wrong number in the wrong spot. Okay, any questions on that one? That's the last one I'm going to do of that type. Okay, let's look at the last type. Victoria, what's different in this one?
We're looking for the hypotenuse.
Okay, we're looking for the hypotenuse. Anything else that's different in what they give you?
We don't have another angle other than 90 degrees.
Right, we're not given an angle and a side. This time we're given two sides. So let's make a sketch, okay, just to kind of see what's opposite and what's adjacent to what. So I'm going to put A, alpha, B, beta. Okay, what do you think I'm okay with you using in this problem, but I wasn't okay in the last two? Yep, Ryan?
Pythagorean theorem,
Right, why am I okay with it this time?
because these are exact numbers given to us.
Yeah, everything you're going to plug into Pythagorean theorem is given. Okay, 3 and 2. So let's find C. How about Connor? When I do 3 squared, I get 9. Okay, Emily, when I do 2 squared?
Oh,
Sorry, yeah.
4.
4. So 9 plus 4 equals C squared. That gives me 13 equals C squared. So Irene, how would I get C?
The square of 13.
Yeah, and since we're solving a triangle, they're usually going to round these numbers off. So let's take the square root of 13. 3.606. Okay, so now we've got C. Connor, am I going to use C to find alpha? No, why not? I could. Is there any reason why I might not want to use C? What have we been saying about answers that you find? What could happen if you use something you calculated to find something else? Sure, you can help him out. What would be a reason to not use that? There's actually two different reasons. It could be wrong. And if it's wrong, then it's not going to help you figure out anything. But even if it's right, why is it still not good to use it? Yep, Emily?
Is it the decimal?
Yeah, because it's a decimal. It's not exact. Okay, so we're going to avoid that for those reasons. If you don't want to do it that way, fine. Do it whatever way you want. But I'm just saying, if you made a mistake, you're going to get everything wrong automatically. Okay, but it's up to you. All right, so now we've got alpha and beta. Just like before, it doesn't matter which one you do first. So how about Rudy? Which one do you want to do first? Beta. Okay, so we're going to find beta. And we're going to use the two things that we're given. So Zach, what's the name of the side that's 2 units long from the perspective of beta? Opposite. How about the name of the side 3 units long? Adjacent. Okay, so Alex, when you have opposite and adjacent, what trig function is that? Tangent. Okay, so now I'm going to find beta. This was finding C. I didn't write it down. All right, so we're going to use tangent. And Cameron, what's the angle that I'm using here? The angle that I circled? Beta. So tangent of beta equals, and what would go on the other side? 2 over 3. Now, before I even start to solve that, what's really different about that equation? There's something different that didn't happen before, but it's happening now. Peter?
You have both the sides rather than the side and angle, so the fractions fold, but you don't have the angle for tangent.
Right, the variable now is inside the tangent function. Okay, this is what you're taking the tangent of. And that angle is protected by the tangent function. Okay, so we have to get rid of the tangent function. How do we get rid of the tangent function? Yeah?
Why do you use tangent?
Yeah, we just don't say multiply, we just say take. We're going to take the inverse tangent. Multiplying can only be done with numbers or letters. Like if you had something like this, and I asked you how to solve that, can anyone tell me what would you say here? How do you solve that? Do what with it? I mean, like, give me a verb in there. Don't make square root into a verb. What?
Divide.
No, not divide by square root. What? Take. Yeah, take the square root. Take the square root of what's on the left. Take the square root of what's on the right. So it's the same thing here. Take the inverse tangent of what's on the left. Take the inverse tangent of what's on the right. Okay. So if you don't have room, just kind of squeeze it in. So you're going to plug all of that into inverse tangent. And you're going to plug all of that into inverse tangent. What's going to happen on the left with inverse tangent and regular tangent? Right?
Cancel out.
Right, they're going to cancel out. Okay. It's kind of like on the calculator if you typed in something like 3 squared and then took the square root. Well, you've got 2 functions here, and you're not multiplying the square root in the square. You're taking them, and they cancel each other out. So you get back what you started with. Any question on why the inverse and the regular tangent cancel out? Okay, so now the only thing that's left on the right is beta equals, and now it's the inverse tangent of 2/3. Now, does that mean multiply inverse tangent times 2/3? Right?
It means to take the inverse.
Exactly.
2/3.
It means to take it. Think of inverse tangent as like this magical box. Like you take and you put things in the box and you get an answer out. That's what you're doing. You're taking 2/3, you're putting it into that function. You're not adding, you're not subtracting, you're not multiplying, you're not dividing. You're putting it in and you're going to get an answer out. Okay? And the answer that you're going to get is some kind of angle. All right, so let's do inverse tangent of 2/3. So we get 33.690 degrees. Now, if you were running out of time on the test and you really just had to get the answer for alpha quick, you could do 90 minus 33.69, and it should be 56.31. But Why is that a bad idea? Connor? Why would it be a bad idea to subtract that angle from 90 to get my answer? Okay, it's a decimal, but that answer that I wrote in red, where did it come from? Like, how were we given that answer? No. So if we weren't given it, why might it be a bad idea to use it?
Could be wrong.
Could be wrong, exactly. So if that's wrong, well, guess what? I just got alpha wrong. But keep that in mind, 56.31, and let's see if that's what we get doing it the way we should. Okay. So now we're going to go back to using the side we were given, the other side we were given, but now we're going to focus on alpha. Okay, what trig function am I going to use here? You want to say, yeah, Al? It's going to be tangent again. You're like, well, wait, isn't that going to give us the same answer again? Nope. Watch what happens. So now we'll find alpha. So Alex, what's going to be the fraction? Tangent of alpha equals what over what?
3 over 2.
Yeah, 3 over 2. So look at the difference. Before it was 2 over 3. Now it's 3 over 2. The reason they switched places is because we switched angles. Okay? Now everything is from the perspective of alpha. It's no longer from the perspective of beta. When you do an inverse trig problem like this, that's how you always do it. All right, it's the same idea. We're going to take the inverse tangent of both sides. And you end up with that. So remember, it should be 56.31. And if that's what we get, then we know it's right because we get the same answer doing it 2 different ways. So second inverse tangent, 3/2, and we get 56.31. Okay, if you want to show the accuracy, it's 310. Great. So any question on that too? Okay, so on the problems where they start you off with a side and a side, you're always going to have to use inverse trig. Okay, always. So on the problem where you have 2 sides, you're going to have to use inverse trig. If you have a side and an angle, like the first case, no, you never need inverse trig. Okay, only for 2 sides. That's another inverse trig one. I'm going to skip that. And let's go to this one. Okay, so this says that you lean a 20-foot ladder against a house. The angle between the ladder and the house is 17 degrees. How high will the ladder reach? Okay, remember, the ladder's not going to reach 20 feet because it's not straight. It's on a little bit of an angle, so it's not going to reach as high. All right, so what do you think you want to do in this kind of problem? Probably the very first thing. Yep.
Draw it out.
Yeah, let's draw it out. And somewhere when we draw it out, what shape do you think is going to pop up? Triangle. Yeah, we're going to get a triangle somewhere. Okay, there's the ground. Here's my house. Okay. I'm going to lean the ladder up against it. Okay, kind of like that. Close enough. Okay, so there's my ladder leaning against the house. What assumption do you think I'm going to make about the house? Because if we don't make this assumption, we can't do it with what we learned this week. Yeah? We're going to assume that the walls are perpendicular to the ground. There are some buildings where that's not true, like the Leaning Tower of Pisa, but we're going to assume that this building is not leaning. It's straight to the ground. Okay, so it says my ladder is 20 feet long. What is my ladder in that triangle? Yep, it's the hypotenuse. And the other piece of information they give me is the angle between the house and the ladder is 17 degrees. So where is that angle? At the top or at the bottom? Between the house and the ladder. Yep, it's at the top. This is the house on the vertical. The ladder is the hypotenuse. So this angle is 17 degrees. How high will the ladder reach? Okay, so what we want to know is x. From here up to the top of the ladder. Okay. So to solve that, we're going to use the angle we were given, the side we were given, and the thing we want to know. So first, let's just figure out the sides, what their names are. Zach, what did we say the 20 was? What's that side? Hypotenuse. So we're not using tangent. Okay, we're using something with sine or cosine. And Hayden, what about the side that's labeled x from the perspective of the 17? Is adjacent because it's right next to the 17. So Zach said we have hypotenuse. Hayden said we have adjacent. So Faith, what trig function has adjacent and hypotenuse in it? Cosine. So we're going to write cosine of my angle equals adjacent over hypotenuse. And Haley, how would I get x by itself? Multiply by 20. Multiply by 20. And that's how high the ladder will reach up the house. Okay, so let's do 20 cosine 17. So we can reach about 19.1 feet. Okay, we can just round it to that. Okay, maybe what I'll do, just to make it clear, I'll put a, since I circled a bunch of stuff, I'll put a box around the answer. Okay. Any questions on that? All right, so that finishes up everything that we're going to do this week. So tomorrow will be a review day. I'll have some problems. It's mostly going to focus on the stuff from 4.1. Okay, the review is not going to focus on the yes/no kind of questions that we did in the last part of 3.1, or what we did on Monday. So it'll just focus on today and the second half of yesterday. Okay, so the homework tonight is on 255. It's 31 through 39 odd, 43 and 47, and 51 to 55 odd. Okay, so first thing we'll do tomorrow, we'll go over that, then we'll do the review. Don't forget, I will be after school tomorrow if anybody needs extra help, especially if you have a test to make up from last academic week. Friday's pretty much it. Okay, if it hasn't been made up by Friday, then it's a 0. Okay.